Hi, sixth grade. Our objective today is I can identify parts of an expression using mathematical terms for multiplication. So for our opening, we have a question that's really important. Why might we use a form other than x when variables are involved? So why can't we use x to mean multiplication anymore? Because x is a letter, and we can get confused if we see this. I don't know if this is 4 times x, or if this is 4 multiplied by a letter x. So it gets confusing when we have letters in algebra and we're also trying to multiply. So instead of using an x, from now on in algebra, you can write your multiplication a couple of ways. You can use a parenthesis, 4 times x, and this is the letter x that stands for any number, or you can use a dot, but your dot has to be up in the center so that it doesn't look like a decimal. There's some vocabulary that you have to be aware of when we're starting algebra. So the first is term. So I kind of did like a word definition example. So a term is part of an expression that can be added to or subtracted from the rest of the expression. And what that looks like is this. 7g is a term, plus 8h is a term, plus 3 is a term. So in this expression, there are 3 terms. We can take away 7g plus 8h or plus 3. We can take this whole piece and move it around. Terms are kind of like chunks or pieces of your expression. And then the other vocabulary word that you need to be aware of is coefficient. So coefficient is a constant factor in a variable term. So in this expression, 4m or 4 times m, ooh, that's another way we could write. You could just say like 4x. Okay, back to this. 4 is constant. It's always the same. 4 never, ever, ever changes. So that is called the coefficient, and it's constant. Think of it like the co-pilot to this m. So 4 is the coefficient in this term. The m is the variable. So the m is not the coefficient, it's just attached to the coefficient. Okay, for the first example, we have 5 different problems, and we're just going to break them apart so that we understand them. 6 times b, remember we don't use the multiplication sign anymore, so I'm gonna write this as 6b, or 6 dot b, or 6 parenthesis b. And let's understand this. 6 is the coefficient, just like we learned up here. So I'm just gonna make notes. 6 equals coefficient, and I'm gonna abbreviate. B is the variable. We can call this a term. We can also call it a product because I know that when I multiply, I'm going to get the answer to a multiplication problem. So that's how we're just going to go through A through E and kind of understand them better. 4 times 3 times h. Okay, so I can do 4 times 3 is 12, and 12 times h I can't do unless someone tells me what to plug in for h. So that's kind of as short as we can write this expression. And 12h on its own could be called a term. My coefficient is 12. H is my variable. I could plug any number in for h. We could also call 12h, instead of just saying this is a term, we could also call it a product, because I know when I multiply whatever h is by 12, I'll get the answer to a multiplication expression. For C, we have a lot to multiply. So 2 times 2 is 4, and 4 times this 2 is 8. So I can write 8ab and that's my new product or my new term. I don't know what A is equal to, and I don't know what B is equal to. So I have to show both of those as variables. My coefficient in this term or in this product is still 8. But A and B are both variables. For D, I can multiply 5 times 3, so I'm going to pull these out. 5 times 3 is 15, but I don't know what M is equal to, and I don't know what P is equal to, so I'm going to show M and P. That's my new product or my new term. 15 is my coefficient, and M and P are both variables. And then our very last example within example 1 is E, and we have 1 times G times W. So you can show this without the X's as 1 GW, but you can also just write GW and leave the 1 out, because when your coefficient is 1, you don't have to write it. It's just assumed that this is 1 GW. So 1 is your coefficient. G and W are variables where we could plug in numbers. But if you were just given this, GW, and they said, what is the coefficient? You would still have to know that the answer is 1. So think of this as like, GW is like great white, like a great white shark. So if I just have GW, I know that's 1 great white shark, even if it doesn't say 1 right in front of it. Okay, so for example 2, we're actually going to expand these expressions a little bit. So in example 1, we actually kind of made them shorter, right? We took out the X's, we figured out how we could write the term in the smallest way possible. But for example 2, we're actually going to expand them and make them bigger. So for A, 5G, I know that means multiplication. So I'm going to put the multiplication sign back into this problem, but I'm not going to use the X. So 5G is going to turn into 5 dot G. And for this, I'll use dots, but remember, we don't want them to look like decimals. So I'm going to put it up toward the middle, 5 dot G. This means 5 times G. For B, I have 7 times A times B times C. So we have a dot in between each of these. For C, we have 12G, and it's not 1 times 2 times G. If they ever have more than one number, they'll break it up, they'll move it around. So it'd be like 1G2 would be 1 times 2 times G. But since this is together, this is 12 times G. For D, we have 3H times 8. So this would be 3 times H times 8. And then finally for E, we have 7 times G times 9 times H. We could also break numbers like this 9 up. So this could be like 9 would be like 3 times 3. So I could write 7 times G times 3 times 3 times H. And I could break up some of these numbers into even smaller factors if you need to for certain problems. Okay, so that's what it looks like when you expand them by putting that multiplication sign back into it. And then we're almost done. Example 3, we're going to start by finding the product of one of these expressions. So I have 4F times 7G. So let's expand that out. 4 times F times 7, times G. We're going to combine all of the terms. So we have 4 terms in this, right? We have 4, F, 7, and G, 4 different terms. I'm going to combine the terms that make sense together. So I can actually do the multiplication for 4 times 7. That's 28. But we don't know what F is equal to, and we don't know what G is equal to. So that's just going to stay times F times G. So if I wrote that back out in the simplest way possible without my dots, this would be 28 FG. So you're kind of expanding it, solving as much as you can, and then simplifying it back down. B, we have a lot more terms once we expand this out. So we'll have 3 times D times E times 9 times Y times Z. And now I don't know what my variables are. No one told me what to plug in or substitute for D, E, Y, or Z, but I can do 3 times 9. So 3 times 9 is 27, and then I would have times D, times E, times Y, times Z. And then if I want to write this in the simplest way possible, we take our dots back out. So this would become 27 D, E, Y, Z. But you know that means multiply. All right, and then the last one like this, double the product of 6Y and 3BC. Okay, so let's just start with this chunk here. We have 6 times Y times 3 times B times C. I can do 6 times 3 is 18, then times Y times B times C. But when they tell me to double that, they mean to multiply it by 2. So now I can kind of tack on this 2 times at the front to show that I'm doing the doubling part of this. So 2 times 18 is 36, and then I still have the rest of this, 36 times Y times B times C, and that's the simplest I can write this if I take out the dots. So 36 Y, B, C, but I know that this really means 36 times Y times B times C. For the closing part of this lesson, I want you to think about what's the difference between standard form and expanded form. Write a little blurb to remind yourself, and then see if you can write a little definition to help you remember what is a factor, what is a variable, a product, and a coefficient. A really good idea is to double check these answers with your partners at your table before you start your practice problem. Thanks so much.